Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rogini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. So now I am going to discuss about the topic on linear block codes. So on completion linear block codes, the students will be able to define linear block codes, define systematic codes, define linear codes. Linear block codes. First, what is meant by linear block codes? For the block of k bits, the parity bits or check bits are added. Hence, the total bits at the output of channel encoder are n. So, the such codes are called n, k block codes. So, here we are having the message block and the channel encoder and code block output. So, the message this will be having the k bits and the message and the check bits. We are having the message as the k bits and the check bit has n minus k bits. So the message and the check bits we are having n bits. So this is the functional block diagram of block coder. Then systematic codes. In a systematic block code, the message bit this will be appear beginning of the code word. So if the message bit will be appeared in the beginning of the code word, so the check bits are transmitted in the particular block. So this type of code word, this will be called as a systematic code. Then linear code. So as the code is linear, if the sum of any two code vectors, this will be produces the another code vector. So if we are having the two code vector, so these are get summed and this will be producing the new code vector. We will call it as a linear code. So this will be mainly shows that the code vector we have to express in a linear combination of other code vectors. So we have to take the code vectors. This will be consist of m1, m2, m3 and so on mk message bit, and this will be consist of check bit c1, c2, c3 and comma cq. So the code vector can be written as x is equal to m1, m2, m3 and so on mk and c1, c2, c3 and so on cq. So where q will be equal to n minus k. So the q is the number of redundant bits. This will be added to the encoder. So the above code vector we have to also written as x is equal to m divided by c. So the m is the k bit message vector and c is the q bit message check vector. So the check bits play the role of the error detection and the correction method. So the job of the linear block codes, this will be mainly generate the check bits. So the code vector can be represented as x is equal to m into g. So x is equal to code vector of 1 cross n size or n bits. M is equal to message vector. This will be having the size of 1 cross k size or k bits. Then G is the generation matrix. This will be having the size of k into n size. So the equation 4 will be represented in the matrix form, that is x of n 1 cross n. This will be equal to m of 1 cross k, then g of k cross n. The generator matrix, this will be depends upon the linear block code. This will be mainly used. We have to represent in the generator matrix g is equal to ik into p k cross q, the whole bracket k cross n. Ik will be equal to k into k identity matrix. P will be equal to k cross q sub matrix. So the check vector can be obtained as c is equal to m into p. So we can write the above equation as c1, c2, c3 and so on cq. The size of 1 cross q, that will be equal to m1, m2, m3 and so on mk, the size of 1 cross k. But the P matrix, that is P11, P12, P1q and P21, P22, P2q, PK1, PK2, PKQ, the size of k cross q. So the C1 will be equal to M1 into P11 XOR M2 into P21 XNOR M3 into P31 XNOR and so on XNOR MK into PK1. This is C1. Then C2 will be equal to M1 into P12 plus M2 into P22 plus M3 into P32 plus and so 1 plus mk into pk2. Then C3 will be equal to m1 into p1 3 plus m2 into p2 3 plus m3 into p3 3 plus and so on plus mk into pk3. So the quiz question is based on the linear block code is the cyclic codes are designed using dash. Thank you.